Let's take a look at van der Waals forces, also known as London dispersion forces. Now, what are van der Waals forces? Well, they're weak attractions between molecules caused by temporary shifts in electrons. These create tiny, short-lived, temporary, partial positive and partial negative charges. Now, just to visualize, let's imagine a neutral atom. We have the nucleus, and then we have a bunch of electrons floating around the electron, like the cloud. And because these electrons are moving around freely, there will be a temporary moment where these electrons will move to a certain side, or majority of them will be on a certain side. This creates a partial negative. I drew that backwards. 1 second. Create a partial negative, sorry. And then on this side, there will become a partial positive. Now, because these are partial, because these create a temporary diploid, these are known as van der Waals forces because they're very weak, and they're weak because they're temporary. And so if we have another neutral molecule over here, because this side is positive and electrons are negative, they'll naturally be attracted towards the positive. So for this one, this side will also become a partial negative, and this side will also become a partial positive. Now, these are due to electrostatic attraction. These are called electrostatic attractions. I feel like this is a better drawing of what I tried to make. So as we see here, the electrons are on this side, making this a partial negative, and then there are less on this side, creating a partial positive. And then over here we see the electrons on this side creating a partial negative because they're attracted to the partial positive of this molecule over here, and so on and so forth. Now, how do we identify a van der Waals force? So we can easily identify them through nonpolar molecules. So an example of how do we find out if something is nonpolar, the easy way is from looking at its model or Lewis structure. A good example would be CO2, because CO2 has 1 carbon and 2 oxygen, so we have 1 carbon here and 2 oxygen here. Now, I obviously didn't draw this accurately, but it's just to visualize. Now, oxygen has a more electronegativity than carbon, and so it's going to attract and hoard more electrons towards the oxygen, and so this is also why its structure is like this, opposed to something like this. Instead of bent, it's like this because it's being stretched, it's being pulled, because there are 2 electronegative molecules on both sides of carbon. Now, if we were to split this in half, it would be symmetrical. So if you were to split this in half and fold it like paper, it would be symmetrical. It's the same on both sides, making this non-polar. So carbon, CO2, is non-polar. Another way to see if something is non-polar is by looking at the general molecule and how it's written. So an example would be dichloride, which is Cl2, and generally when you see the 2, you would think that this is non-polar. Now, another example would be dibromine, Br2, and because these 2 are diatomic molecules, they would be non-polar, and that is kind of how you would dumb it down to find out if something is using the van der Waals forces. Thanks.